The integrating factor is given by e raised to integration of p into dy. Here it is dy, therefore dy here. So what is p? In this case our p is this and our q is this. So our integration is e raised to integration of y into dy. What is integration of y? Integration of y is nothing but y square upon 2. So this is our integrating factor, and the solution for this equation is given by u into integrating factor equal to q into integrating factor into dy. Why dy? Because in the denominator we have dy plus some constant. So what is u? U is nothing but 1 upon x. So u is 1 upon x. What is our integrating factor? Our integrating factor is e raised to y square. So e raised to y square upon 2 is our integrating factor. What is q? Q is minus y cube into integrating factor is e raised to y square upon 2 into dy plus some constant. So this minus sign we can take out of the integration and it will become minus of y cube into e raised to y square upon 2 dy. This is a very different integration. So what I am going to do here, I am going to substitute e raised to y square equal to some another variable. So y square upon 2 I am going to substitute as t. If I take this derivative, so it will become 2y into dy upon 2. This 2 will remain as it is equal to dt. So this 2 and this 2 will get cancelled and our y dy is nothing but dt. Here instead of y cube I am writing y square and this e raised to y square upon 2, and instead of dy I am writing y into dy. So why I am writing it as y dy and here y square, so that I can replace y dy by dt. So I am going to replace this whole term by dt, and e raised to y square is nothing but e raised to t. What is y square? From here y square is nothing but 2t. This our new equation will become 2t. So this is our new equation. As you can see, 2 is constant, so it can be taken out of the integration sign, and our new integration is t into e raised to t dt. So as you can see, this is nothing but the simplest integration of t into e raised to t dt. Here we are going to use the property of integration, that is u into v rule of integration. What is u into v rule of integration? U into v rule of integration is nothing but u will remain as it is, integrating v minus integrating derivative of u, integration of v. So this is our property of integration. Here also we are going to use the same property. So u remain as it is, then integration of v and integration of e raised to t is nothing but e raised to t minus integration derivative of u, derivative of t is 1, and integration of v is e raised to t. Then again we have to take this integration, so it will become t into e raised to t minus integration of 1 into e raised to t is nothing but e raised to t. So this is the solution of this part. So instead of t into e raised to t, we can write this term. So our final solution is 1 upon x into ey square by 2 and this minus 2, and the value of this integration we got as e raised to t minus 1 plus c. But here everything is in the y square, so we are going to substitute our t. Our t is nothing but y square upon 2, so this will become e raised to y square upon 2 into y square upon 2 minus 1 plus some constant. So this is the solution of this problem, and this is how we solve the problem on type 4b. More such types we will see in our next video, so stay tuned for our future lectures.